Hi everyone, it's Mr. Denny. So what we're going to do is an example problem on how to create what's called a bounded synchronous counter. So, as you know at this point, a synchronous counter, we have our flip-flops. I'm going to make a 3-bit synchronous counter. So for synchronous counters, we have to use JK flip-flops. So JK are Q and Q naught ports and our inverted clock. These are 74LS 76 chips. I'm not going to label all of the chips here. They're all the same. All right. And so our first step here is going to be, come down here and write our steps. Our first step is to set up a standard synchronous counter with enough bits. So this is based on the highest number you're counting to or counting from. A 2-bit counter will count up to 3. 3-bit counter will count up to 7. 4-bit counter will count up to 15. And basically the formula for this is you're just going to take whatever number you have here, let's call it n, it will count up to 2 to the power of n minus 1. All right. So we're going to set up a synchronous counter with enough bits. So I'm going to go ahead and do that. Remember, synchronous counter, all of the clock pulses are tied back to the same clock. And we have the JK on our least significant bit are tied just to power. And all of the JKs on these subsequent ones are tied to the Qs from the previous chips. So my second one here is the Q from the first chip, and my last one is going to be the Qs from both of them ANDed together. All right, so there's our basic counter. And now as it is, this counter would count from 0 up to 7. Remember, if I wanted to make this count down, instead of coming from my Qs to my J and Ks, I'd be going from my Q naughts. So I have my first step here. I've made a basic counter. Now there's a little bit more to the JK flip-flops that we haven't drawn in here. They also have their presets and their clears. So we draw our presets on the top, our clears on the bottom. The inputs for both the presets and clears are inverted as indicated by those little bubbles. Our next step, and we're going to do this one in red. So our next step is based on the count. So let's say for our example, we're going to count from 3 to 5. So that means we'll go 3, 4, 5, 3, 4, 5, etc. All right, so based on the count, determine what number you reset on. So if I'm going from 3 up to 5, I'm resetting on 6. So once I go 3, 4, 5, the moment I hit that 6, I want to reset back to 3. All right. If I was going from 3 or from 5 down to 3, so 5, 4, 3, I would reset on 2. You get the idea. If I was going from 5 up to 11, I'd reset on 12. If I was going from 11 down to 5, reset on 4. All right, so basically it's the next number after the last number you've counted. All right, and we're going to write that number in binary. So for our example, we're going from 3 to 5, we're resetting on 6, and 6 in binary. So in our example, our 6 becomes 110. All right, this is our most significant bit and our least significant bit. All right, so we have 110. Basically, we want something to happen when we hit that number. So what we're going to do is we're going to tie in to the Q's and Q naughts to get that binary number. So I want 110. Down here, this is my most significant bit. This is my least significant bit. So I want this to be 1, this to be 1, and this to be 0. So when this is a 1, we're going to be looking at Q then. That means Q is going to be 1. When this is a 1, Q is going to be 1. And when this one's a 0, that means Q naught is going to be the 1. So we're going to take these three, and we want something to happen when we have that 110, that Q, Q, Q naught. So I'm going to AND them together. Now here's the thing though, we're eventually going to use this to connect to our presets and clears, and our presets and clears are actually activated by a low signal, by a 0. So we're not going to AND them together, we're going to NAND them together. All right, so that's our second step. We've looked at the count, we've figured out our reset number, and we've tied those into our Q's and Q naughts. All right, our third step. Use the output of the NAND. Now remember, you may have a 2-input, 3-input, or a 4-input NAND to connect to the presets and clears to go to the first number of the count. So for us, we're counting from 3 to 5. So for us, if we're going from 3 up to 5, our first number is then 3. If I was going from 5 down to 3, our first number